From our table of trig substitution, you see that this is the second category, so we substitute x as 8 tan theta. So we said let's x equal to a tan theta. So the x is now a sec squared theta. Therefore, the integral, we're going to split it into two. I'm doing for the addition after we do for the subtraction. So it's now x squared. X squared is now a squared tan squared theta plus a squared. So I'm doing for this first addition after we do for the subtraction, and dx. And our dx, we've seen that ds is a sec squared theta d theta. Sorry, let's put d theta. So which is now integral of 1 over, we'll factor a squared is 1 plus tan squared theta a sec squared theta d theta. This is equal to, let's start writing, let's write this one over, this is, remember the square roots, this is sec squared theta. 1 plus tan squared is sec squared theta, and the square roots, this is a sec square theta d theta, while the square root of this is now a sec theta. So we now have integral of sec theta d theta, and integral of sec is ln sec theta plus tan theta. That's the integral of sec. But remember, we are given x and a, so we need to substitute back. So with that, we see that we can form a right angle triangle using x equal to a tan theta. Tan theta is now x over a. So let's look at this so that we can get sec theta and tan theta. Okay, look at this. They state tan theta is x over a. That is, if here is theta, tan is now x over a. So the hypotenuse will be x squared plus a squared on square roots. So we see that since tan theta is x over a, that's from this, implies that sec theta means 1 over cos theta, and cos is a over this. 1 over cos is now x squared plus a squared over a. Yes, since cos is adjacent over hypotenuse. So we'll go back and finish up. So this is ln sec is this over a, y tan is x over a plus k, and we can write it, they have the same numerator, so I can write this as they have the same denominator. I can write this as, I started with this x plus x squared plus a squared over a plus k. And from our laws of logarithm, we can split this as ln x plus a squared plus that minus ln a plus k. Remember, a is a constant, therefore to evaluate the integral of x squared plus a squared on a square root dx is now equal to ln x plus that plus k. Do you know why? Because this is also a constant, and constant plus constant will always be a constant, whether plus or minus. So that's the integral of this. So we've gotten the formula for the addition. Let's do for the subtraction. So in the subtraction, looking at our table, trigonometric substitution, we substitute a square root of this as a sec theta. So let's do the same. So we now say let x equal to a sec theta, which implies that the x is now a, if you differentiate sec, is now tan sec theta. Therefore the integral is now 1 over x squared is now a squared sec squared theta minus a squared, and the x is a tan theta sec theta d theta. That's our dx, which is now integral of a tan theta sec theta over, this is square root of that, factor a squared, which is now integral of a tan theta sec theta over square root of a squared is a, sec square theta minus 1 is tan square theta, and square root of tan square theta is tan theta. So this is integral of sec theta d theta. So we still get ln sec theta plus tan theta. So if you look at the one we've done, if you look at for the addition, we still got the same answer. Do you see it? We still got the same answer. We draw the same triangle here, the same triangle, but different values. So that same triangle, but in this case our theta is opposite. This is sec theta, that's cos theta is now a over x, so we have a over x, so this is now square root of x squared minus a squared. So that tan theta will be, this is theta, tan theta is this square root of x squared minus a squared over a. So we substitute, this is now ln sec theta is x over a, while tan theta is square root of this over a plus k. So we see that the integral of 1 over x squared minus a squared dx is now equal to ln x plus square root of x squared minus a squared. Instead of writing minus ln a, no need. So what am I trying to say? Therefore, to get the integral, we now generalize, just the difference is the sign. Here is minus when you are giving minus, while the former one was plus when you are giving plus. So we see that the integral of square root x squared plus or minus a squared dx is now ln x plus square root of x squared plus or minus a squared plus k. So they are the same, just the sign here. So let's look at this question. We're asked to evaluate the following. So we'll be using the two formulas. That's that the integral of 1 over s squared plus or minus a squared dx is now ln x plus square root x squared plus or minus a squared plus k. So that's what we'll be using to solve all the questions. So the first one has minus 4 is 2 squared. So the answer is ln x plus square root of, do you get, we are using this, so which is x squared. Since we have minus 2 squared, which is 4. So that's our answer, plus k. The second one, we have addition. 50 is root 50 all squared, root 50 all squared dx, which is ln x plus s squared plus 50 plus k. So why the third one? The third one, integral of 1 over, but this, remember, if you check, the coefficient of x squared here is 1, so we need to make the coefficient 1. So by factoring 3, I have x squared minus 5 over 3 dx. And we know square root of root 3 is root 3. So we'll bring out the root 3, square root of x squared minus 5 over 3, or in square root dx. You get square root of this. Using laws of such, we square root the product, each of them, and this is a constant, which is 1 over root 3 integral of 1 over square root of x squared minus 5 over 3 all in square root squared, so that it will be in this form. So the answer is 1 over root 3 ln x plus the square root of which is x squared minus 5 over 3 plus k. Though we can solve further, we can clear the fraction. If you multiply both of them, we'll have over root 3, square root of root 3, and multiplying both by root 3 because of the denominator. So we can write this as 1 over root 3 ln root 3x plus square root of 3x squared minus 5 plus k. So the last, okay, we are for the last two, d, we can write this as integral of x squared. So we need to make this a perfect square. So coming to this, we can write this as, we'll add 9 over 4 to make it a perfect square after subtract the 9 over 4. So we are still correct, dx. We are correct. So this is now integral of, this is a perfect square, which is x. Square root of x squared is x. Square root of 9 over 4 is 3 over 2 all squared. This is a perfect square. This is now minus 49 over 4. This is minus 49. So this is now integral of x plus 3 over 2 all squared minus 7 over 2 all squared, all in square root. These are all in square root. So our answer is now, using our formula, is now ln our x is now x plus 2. That's this, plus square root of all this, and all this is this which is x squared plus 3x minus 10 plus k. Though we can still make it neater by multiplying by, we can decide to multiply by, okay, let's do this here, len, multiplying both by 2, you know this is over 1, so 2 times, that is 2x plus 3 plus 2 root x squared plus 3x minus 10 over 2. But we know that if we subtract, len 2 is a constant, so no need plus k. So that is the neater answer. So for the last one, we have 1 over. So the first thing we have to do is to factor 4. So I have x squared minus 5x plus 75 over 4. That's the first thing, integral. And square root of 4 is 2, so we'll bring out the half. That's 1 over 2 of 1 over the square root of x squared minus 5x plus 75 over 4 dx. And we can write this as making this a perfect square, so which is x squared minus 5x. We always add 25 over 4 to make it a perfect square, but we need to subtract back to avoid changing the equation, plus 75 over 4 dx. So which is now 1 over 2 integral of 1 divided by square root of, this is now a perfect square, which is x minus 5 over 2 all squared. So we'll now add this is 50 plus 50 over 4 dx. So this is now half len x minus 5 over 2 plus the square root of all this and all this and this are the same, and also this, so x squared minus 5x plus 75 over 4, remember all in square root, plus k. But we can still finish the work, which is half len. If you, the LCM here is 4, so we'll have 4x squared minus 20x plus 75 all over 4, all in square root. Square root of 4 is 2. So to clear the fraction, we'll multiply all by 2. We have 2x minus 5 plus square root of 4x squared minus 20x plus 75. So instead of subtracting minus len 2, because we have all over 2 now, all over 2. So but there are still a cost, they are all constants, so that's the answer. So it's a very tricky question, but we've solved all. Thank you.